All right, so what we're looking at, without using a calculator, find all the values of theta degrees between 0 and 360 degrees for each of the following. The example I've been asked to go through is cos of theta degrees is equal to negative root 3 on 2. So, first things first, let's think about where we are going to be operating. CAS T. Now I care about a negative answer. So what quadrants am I going to be operating in?
Second and third.
I'm going to be in the second and third. So second and third, because those are where cos values are going to be negative. So let's think about positive. All right, so if we run down our exact values table.
30.
So 30, 45, 60, 90, 0. So sine is 0, root 1 on 2, root 2 on 2, root 3 on 2, root 4 on 2. That's sine. And then cos is the opposite. Or 1, or 0. So we're dealing with causes of 30. So that means that our reference angle that we're working with is 30. But we are over here. What is, so if that angle is 30, what's that?
150.
150. And then in this quadrant here, that angle is going to be 30. So what is that angle?
210.
210. So cos of theta equals root 3 on 2. The answers are 150 and 210. Set my CAS to degrees. Standard. Negative root 3 on 2. Ta-da!
So how would you do this question with the CAS?
So if I was allowed to use the CAS,
Yeah.
Easy. So cos, so I would go solve cos x equals keyboard negative root 3 on 2, and then I would go 0 x 360 and then would spit out the answers there for me.
Nice.
All right. So there's my CAS. So I've got negative root 3 on 2, and I've got a vertical line that splits what I'm working on, and then I've got my restriction. Because if I don't put the restriction in, this is what happens. It just spits out a whole bunch of infinite solutions. That's why the question itself says between 0 and 360. All right, so that can go in and put it into your question to restrict it for you. All right, and that's the easiest way to do it with the CAS. All right, how do you convert degrees to radians? So what you do is to convert degrees to radians, you multiply by pi on 180, and then if you want to go back the other way, you multiply by 180 on pi. So if I wanted to work out what is, so we'll go 150 degrees to radians, so that'd be one.
So the calculator is on the way.
Oh, yeah, sorry. I'll do 150 pi over 180. I've got 30 here. So it's 30 times 5. And then here I've got 30 times 6. The 30s cancel out and I'm left with 5 pi on 6. If I want to go backwards and I want to go back to doing degrees, I would go, well, say for example, if I've got 3 pi, I would times it by 180 over pi. The pi's, what's pi divided by pi? They cancel out. And then I'm left with 3 times 180, which is 700, sorry, not 720, it's 540. All right, and if I have a weird one like 7 pi on 9, I'd multiply that by 180 on pi. The pi's go away. 180 divided by 9 is 20. So the answer is 140. If you can remember the important thing that 2 pi is equal to 360, which means that 1 pi is 180, which means that pi on 2 is equal to 90, so pi on 4 is 45. You can quickly run through the conversions pretty quick. This one is the important one. So 1 pi radians equals 180 degrees. So 1 radian equals 180 divided by pi degrees. And if I wanted to go backwards and figure out what 1 degree was, it would be pi divided by 180.